This video is on area polar region, and what I have in this video is I have two curves here. The circle here, this is r equal to 4 sine of theta, and then the cardioid is r equal to 3 minus 2 sine of theta. And what I want to do is find the area that is inside both curves, or that is common to both curves. And so here are the graphs of both curves. And so we want this region right here. And so to find the area of the region that is inside of both curves, what we can do is just find the area of this part right here. And then just double it. So find the area of this part, this piece right here, and then double it. And so the first thing we need to do is find this point of intersection right here, so that we know where to start. And so once again, this is the graph of the circle, and then this is the graph of the cardioid. And so to find the intersections, we just set the two equations equal to each other. So we have 4 sine of theta equal to 3 minus 2 sine of theta. Add 2 sine of theta to both sides, and then we get 6 sine of theta equal to 3. Divide both sides by 6, we get sine of theta equal to 1/2. And then recall that sine of pi over 6 is 1/2. Sine of 5 pi over 6 is 1/2. Sine of 13 pi over 6 is 1/2, and so on. And so now I'm going to graph from 0 to pi over 6. And we can see that we do get the point of intersection, and when theta is equal to pi over 6. So once again, at this point right here, the point of intersection, this is when theta is equal to pi over 6. And so now let's figure out how to find the area of this region right here. This line right here, this is the line theta equal to pi over 6. So what we can do is find the area between this line, the line theta equal to pi over 6, and the circle. And then find and then this area is bounded between the line theta equal to pi over 6 and the graph of the cardioid, r equal to 3 minus 2 sine of theta. So this is what I'm planning to do: find this area, and then find this area, and then add them together, and then that will give us the this part right here. And so this area, the yellow shaded region right here, the area will be from the integral from 0 to pi over 6. And recall that this is the formula 1/2 f of theta squared d theta, the integral, to find this area right here. So it would be 0 to pi over 6. And then f of theta is r equal to 4 sine of theta, so squared. And then 1/2 times 4 sine squared of theta, which is 8 times sine squared of theta. And the integral for sine squared, recall that sine squared from trigonometry is 1 minus cosine of 2 theta dividing by 2. And this is the same as 1/2 minus 1/2 cosine of 2 theta. So the integral for 1/2 is just 1/2 theta. And then here we have minus 1/2. And then the integral for cosine of 2 theta is 1/2 sine of 2 theta. So we end up with 1/2 theta minus 1/4 sine of 2 theta. And so this integral right here is, so we have 8 times 1/2 theta minus 1/4 sine of 2 theta. And then evaluate from 0 to pi over 6. So when theta is pi over 6, we get 1/2 times pi over 6, which is pi over 12. And then here we get 2 times pi over 6, which is pi over 3. And so here we end up with 8 times pi over 12 and then minus 1/4. And then recall that the sine of pi over 3 is the square root of 3 over 2. And then simplify, we get 2 pi over 3 minus the square root of 3. And so the area of this shaded, yellow shaded region right here is 2 pi over 3 minus the square root of 3. And then now we need to find this area right here. Now for this area right here, which is between the graph of the cardioid and the line theta equal to pi over 6. So at this point theta is pi over 6. And then when we right here, this is when theta is pi over 2, when we're at this point. And so we'll integrate from pi over 6 to pi over 2. And then again, this is the formula for the area of the polar region. So we get 1/2, and then f of theta, the cardioid here, the graph is 3 minus 2 sine of theta, and then squared. And then simplify, we get 9 minus 12 sine of theta plus 4 sine squared of theta. And then the integral will be 9 theta, and then minus 12. And then the integral for sine of theta is negative cosine of theta. And a few moments ago we have seen that the integral for sine squared is 1/2 theta minus 1/4 sine of 2 theta. And then simplify a little bit more. For this part right here, we get 2 theta, and then 4 times 1/4 is just sine of 2 theta. 9 theta, 2 theta, 11 theta, and then times a half, so we get 11 halves theta. A half times 12 is 2, and then 1/2 times sine of 2 theta is 1/2 sine of 2 theta. And then we need to evaluate from pi over 6 to pi over 2. So when theta is pi over 2, then we get 11 halves times pi over 2, which is 11 pi over 4. And then when theta is pi over 2, cosine of pi over 2 is 0. And then when theta is pi over 2, we get 2 times pi over 2, which is pi, and sine of pi is 0. And so we get 0 here, 0 here. So we just get the 11 pi over 4 for the upper limit of the integration right here. And then now let theta be pi over 6. So when theta is pi over 6, 11 over 2 times pi over 6 is 11 pi over 12. And then cosine of pi over 6 is the square root of 3 over 2. And then pi over 6 here, we get 2 times pi over 6, which is pi over 3. And then sine of pi over 3 is the square root of 3 over 2. And then simplify, we get 11 pi over 6 minus 11 times the square root of 3 over 4. So the area for this region right here, I call it a sub 2, is this. And then we found the area for this region, which is a sub 1 earlier. So in summary, the area of this region right here, which is I call it a sub 1, is 2 pi over 3 minus the square root of 3. And then the area for this piece, which I call it a sub 2, is 11 pi over 6 minus 11 times the square root of 3 over 4. And then simplify, this is what we'll get, which is approximately 1.35879. So the area, once again, for this piece right here is 1.35879. And then the area that we want is this region right here. So we just double this, and then we get 2.7175822. And that's the end of the video.